Okay, today we have Math 3, Unit 1, Section 5. So to start with, recall the domain represents what of the function? Very good. The x values. A couple other things that well, let's go ahead and read this. Sometimes functions have the domain restricted to be a subset of their original domain. So you know how you have a big graph, but what's going to happen is they're going to be like, we only want this piece of it. So they're going to give you restrictions, like your x can only go from here to here, and that's the only part of the graph that we're actually going to look at. When this is the case, the function should only be graphed based on the domain restrictions. Another thing is that you have your inequality signs. So remember, and I'm just going to kind of write this at the top, if you have greater than or equal to or less than or equal to, that will be a solid circle, and that means that it's equal, right? If you have less than or greater than, you have an open circle. When you're using interval notation, remember that this is where you would have your brackets, but if it was an open circle, you have parentheses. Okay, so this is just kind of as a reminder. Hopefully you remember this. Just kind of making it a chart. Okay. All right, so first of all, when you look at this, what type of graph is that? So we've done lines, we've done parabolas, we've done exponential functions, we've done absolute values. What is it? It's called a line. Yeah. Okay. All right. So this is a line. When you're graphing a line, how do we normally graph it? Good, from the y-intercept. And then on this problem, what is the y-intercept? Good. So in here, my m is something, and my b is 3. Okay, what is my m on this one? -2. And that could be -2/1. Now, you have a couple ways of doing this. You could graph this without the restrictions and then go and put the restrictions in. Or you can figure out what the restriction is. Sometimes I think it's easier to graph it first and then go back and fix it. So what do I mean by that? Let's go ahead and make sure you're using pencil and not pen. So if I were to graph this, I would go up 3, 1, 2, 3, make a point. And then from there, using my slope, I would go down 2, right 1, or I could have gone up 2, left 1. And I'm going to draw a line. Okay, so here is my line. Now, it says that x has to be greater than or equal to 0. Where is x equal to 0?
On the x-axis.
So at the x-axis, okay, here's my x-axis at 0. Do we all agree with that? So that means that the answer at 0 is right here. So can it be equal to that value? Yes, because that's the equal to sign. And then it has to be greater than. So which values are greater than 0 for x? Is it going to be part of the line going to the right or the part going to the left? Going to the right. Because x values are bigger going to the right. Okay? So that means we have to erase this other side because that's where the x values are what? Less than 0. Okay? So there is my graph. And then now we need to state the domain and the range. So for my domain, and that's my x values, it starts at what? 0. And would it be a bracket or a parenthesis? Bracket. And then it goes all the way to? Good, positive infinity. And with infinity, we always use a? Good. Okay, our range. So remember, I always go smallest to largest. What would be my smallest value on the range? Negative infinity. And it goes all the way up. And this, what is this value on the y-axis? 3. And would that be a bracket or a parenthesis? Very good. That's it. So far, so good? Okay. All right, let's move on to the next one. So we have x minus 3 squared minus 4. What type of graph is that? No, exponential is when you have x in the exponent, like a variable in the exponent. What do you guys think this one is?
It's the
Parabola. It's your u, okay? Or a quadratic function. We'll put parabola. Okay, so with the parabola, what do we do first?
Find the
Vertex. And what would be my vertex on this one?
3, -4.
Okay, so we're gonna go positive 3 up 1, 2, 3. Oh wait, sorry. Right 1, 2, 3. Down 1, 2, 3, 4. Okay. Okay, and would this parabola go up or down? Up. Okay, let's go ahead and see here. They're saying that they want x to be less than 4. So we're going to plug 4 into this equation. Okay, so we get 4 minus 3 squared minus 4. So all I'm doing is plugging in 4 for the equation. What is 4 minus 3? 1. And so then we would have 1 squared, which is 1, and 1 minus 4 is
-3.
-3. So that means at the ordered pair, 4 comma -3, that is going to be one of the limits of my graph, one of my restrictions. So let's go here, right? 1, 2, 3, 4, down 1, 2, 3. And so this is where x equals 4. So this is like where my graph is going to be starting. Is it going to be an open or a solid circle there? Open. And why? How do we know that it's open?
X is not less than or equal to.
Good. It doesn't have the equal to sign underneath here. So normally, you know, this parabola would make a U like this, right? Well, in this case, we're starting here and it has to be less than 4. So that means we're going to, from this point, we're going to go left. And so that is going to be my graph. So remember on this one how x was greater than, so on the graph I went to the right for all the x values to the right. On this one, since it's saying less than, I'm doing all the values to the left. Is that clear? Okay, so write down what you think your domain and range is on this one. Remember, you always go smallest to greatest. Okay, what do we think the domain is? What's the smallest domain value? Smallest is -infinity. Okay, because remember we're going left and how this is shooting this way. It's -infinity. And then my largest x value goes to 4. And would I have a parenthesis or a bracket at 4?
Parentheses.
Parenthesis. And again, why is it a parenthesis? Because it's not equal to. Very good. Now for my range, going on my y, my up and down, what is my smallest value on the y-axis? It's at -4. And is it going to be equal to? Is it going to be a bracket or a parenthesis? A bracket. Okay, so it's open here. This is actually a 3 on the y-axis, but here, this point, even though I didn't draw it great, this point right here, it's filled in. So this is the only one that's open. And then from here up, it's, so I'll draw it right. Okay, and then it goes all the way to what? Good, and that has the parenthesis. Do you guys want to ask me any questions about that so far? Okay, what type of graph is our next problem here on the bottom left? Very good, this is a parabola. And on this parabola, what is my vertex? negative 3, 0. So we're going to go ahead and plot that point. We're going to left 1, 2, 3, and then up 0. So there's a point. And they're telling us that this time they want our graph to be between negative 4 and 1. So we need to find out the x value at negative 4, or plug in the x value at negative 4 to find out what y is, and the same thing for negative 1. So we're going to plug negative 4 in here. So we have negative 4 plus 3 squared. What is negative 4 plus 3?
Negative 1.
Good. And what is negative 1 squared?
Positive 1.
Positive 1. So this ordered pair right here is at negative 4, positive 1. At negative 4, is it equal? Yes. So I'm going to go left 1, 2, 3, 4, and up 1, and I'm going to make a solid point there because it's equal. Sorry. Okay, next I have here negative 1. So what am I going to do with the negative 1?
Plug it in first.
Good. So we have negative 1 plus 3 squared. What is negative 1 plus 3?
Positive
Good. And then 2 squared is?
2. 4.
So this ordered pair is negative 1, positive 4. Now on this one, does it have an equal to sign?
No.
No. So at negative 1, 4, I'm going to have an open or a closed circle? Open. So we're going to go left 1, up 1, 2, 3, 4. And I'm going to make an open circle. Okay, and we already decided this was a parabola shape. So we can see it starts here and it curves to here. So that's the only part of my graph that's there. So now we need to figure out the domain and the range. We're always going smallest to biggest. So my domain on this problem, what is my smallest x value? What was it? Good. And is that a bracket or a parenthesis?
Bracket.
Good. So negative 4, and then my largest x value is at what?
Negative 1.
Negative 1, and that would be a,
Parentheses.
very good. Now let's look at our range. What is my smallest range value?
0.
Good. So you can see this point on the y-axis, it's at 0. Okay? And is that going to be a bracket or a parenthesis?
Go bracket.
Good. So that's 0. And then my largest y value is up here, and that value is at
4.
4. And is that going to be a bracket or a parenthesis? Perfect. Okay. Do you guys have questions right now? Okay. So what type of graph is this one going to make? It's absolute value. And do you guys remember what type of graphs, what they look like with absolute value? V's, okay? So I'm just going to put here absolute value, and then I'm just going to put a V, okay, to remind myself. So what is my vertex on this original problem? Very good. 0, 4. And we know that this graph is going to end up going which direction? Down. And how do I know it's going down? Good. The a value is negative. It's a negative 1 in front. And we could even write a equals negative 1. Okay. So we're going to go and plot this point. So we're at 0, and we're going to go up 1, 2, 3, 4. Oops. And for right now, I'm just going to make that a solid dot. If we have to go change it later, we can. Okay, now they're wanting this domain from negative 3 to 5. Okay, so we have to plug in and see what the value is at negative 3. So all we do is put this information into our equation. So I have a negative absolute value of negative 3 plus 4. What's the absolute value of negative 3? 3. So this changes to be 3, but then I saw the negative outside, right? And so we have negative 3 plus 4, which equals 1. So this ordered pair is negative 3, 1. Now, at negative 3, is that going to be an open or closed circle? Open. And again, we know that because
It's not equal to.
it's not equal to. Very good. So left 1, 2, 3, up 1, open circle. Good? Okay, so now we have to do the same thing at 5. We'll plug in 5 here, so I have negative absolute value of 5 plus 4. The absolute value of 5 is 5, so I have negative 5 plus 4, which equals negative 1. So this ordered pair here is at 5 comma negative 1. So is this going to be an open or a closed circle?
Close.
And we know it's a close because it has a equal to sign. Good. So we go 5 down 1. I make a closed circle. And then we know this is an upside down U. Did it make an upside, or not upside down U, upside down V? Did it make it if we connect the dots? Yeah. So we just draw our lines in. Hopefully you can draw better than me. So I should use a ruler. Okay, anyways. All right, so domain and range. What will be my domain on this one? What is my smallest x value? Good, parenthesis or bracket. Good. Negative 3, and it goes all the way to 5, and is that perfect? Okay, range, what's that? What's my smallest y? Bracket or parenthesis? Good. So again, notice how negative 1 is right here, okay, and it has a closed circle, and then my highest value for my range, or my y, is what? 3, and is it a bracket or a parenthesis? Wait, that's supposed to be a 4. I did not plot it right here. So it should be a 4, and I'll fix this. And it should be a bracket. Good. Okay. Any questions? No? All right, let's move on. Okay, so what type of function is my next problem? Good job, exponential. And do you guys remember what the exponential function looks like? Okay, it's the ones that we did yesterday, and it, like, you know, where it gets close to the 0 and shoots up, right? Okay. So, and remember, how did we end up graphing these?
By putting at negative 5, that would be like where it's close.
Well, okay, so remember we start with this, the 3 to the x, remember? Yeah, and so you have 0, 1, and then I would have 1 and 3. So remember, these are kind of like my fake points. So if I go, and then this minus 5 is telling me to do what?
Move down.
Good, that means down 5. So if I start at 0, 1, I'm going to go down 5. 1, 2, 3, 4, 5. I'm going to go ahead and make these points for right now, and then we'll figure out what's going on. And then on this one, it's right 1, up 1, 2, 3. But then from there, I have to go down 5. 1, 2, 3, 4, 5. And then where would be my asymptote on this problem? Where is it? Negative 5 is right. Okay, so I'm just going to kind of draw that in. And we know how my curve should end up being, right? But let's not draw anything because we actually need to see what's going to happen. So the only restriction here is that they're saying x cannot equal 1. So we're going to plug 1 in here and see what happens. Okay, so we have 3 to the first power minus 5. What's 3 to the first power?
3.
And 3 minus 5 is? Negative 2. So at the ordered pair 1 comma negative 2, the graph cannot equal that. So let's go right 1 down 2. And so this point, it's not going to be a solid circle, it's going to be a what? Open circle. Okay, and then, so everything else is fine, it just can't equal that point. So this, we go from here and it goes curves and gets close to our asymptote, and it's going to shoot up like that. Is that okay? Now this is the one where writing your domain and range is a little different, okay? Because there's like a piece in the middle that's missing. And so it's actually kind of like the union of two graphs, okay? So what happens is for our domain, let's kind of talk through this. So from here to this point, what is the domain? So we have negative infinity for our x values, right? And then it goes all the way to 1, and then it's going to be a parenthesis because it can't equal that. And then we're going to, it's a union, and it's a U. It's like an uppercase U, but it doesn't have the line going down. That represents union. And then now we're going to do the second half of this graph. And so that, again, is going to be a parenthesis, and it starts at 1, and then it's going to go all the way to positive infinity. Okay? It's the same thing with the range, because this is also a range value, right? And so we are going to have a union on this one as well. So do you guys want to give it kind of a try? See if you can write it correctly. Not sure. Okay, so what's this? You're not sure on this one? Okay, let's go back to this one. So remember x and y goes right and left, right? Okay, I'm going to kind of like block some things here. So do you see how from it can't equal 1? So we went negative, we're looking at the x right now, okay? So negative infinity up to 1 is right there. Okay, negative infinity to 1. So you have to have two separate statements because it can't equal 1, but it's left of the 1 and right of the 1. Most of our other graphs, it stopped at specific points, but this it's going on forever in both directions except for that 1 point. So then after I write this value right here, it's a union, so it's included with, and then it goes here and you start at 1 and it goes to positive infinity. So you just kind of have to say each piece.
So you just break it up.
Yes. So as you can see on all of our other problems, they went either in infinity in one direction and stopped, or it stopped in two directions. This one, it's like you just have a stopping point in the middle, but then it continues on both sides. So you have to state it as two separate things. So it's the same thing with the range. What is your smallest range value? So looking at the x and or at your y-axis now, what's my smallest y value? -5, but it's, remember, it's getting close to -5, but it never actually touches -5, so we're going to use a parentheses. Okay, so I have a parenthesis at -5, and then where it doesn't touch, what value is that on the y? -2. And again, since it can't equal that value, we put a parenthesis, and then it's a union, and we have another parenthesis, and we're going to keep it at -2, so it's like that's just our space, and then it's going to go where? To positive infinity.
So pretty much if you're doing the whole thing, you go -5 to positive infinity.
Yes. So if this was not closed, I mean, if this was closed and not open, yes. Okay? Are we better with that? Does anybody have questions? Okay, next one. This says f of x equals -2. What that really means, remember f of x is the same thing as saying y equals -2. Do you guys agree? So what kind of graph is y equals -2? What? It's a line. Very good. And that line is horizontal or vertical? Horizontal, going through the -2, okay? Now, they're saying that your restriction is that x can only equal 3. If you plug in 3 for x, is this going to change that value? No. So when f is 3, y is still -2. So all you're going to do is plot the point 3, -2. So write 1, 2, 3, down 1, 2. Because that's what they're saying. X can only equal 3. Now, if I had actually drawn the graph, it would have been a line through there, right? But they only want that 1 point. So what is my domain? What are my x values? 3. What's my range values?
-2.
Yep, that's it.
Can every problem on the test be like that?
I know, huh? Seriously. I'm with you. Okay. So now it's the working backwards. Okay. So it says write the function and its restricted domain for the given graphs. First of all, what type of graph is this?
It's a
Parabolas. Good. And parabolas are in the form, you know, y equals ax squared. Correct? Okay. So one of the most important things with parabolas is that you know the what? This one, we want to know the vertex. Okay, remember? And so we have to put that into our equation. So what is going to be the vertex on this problem?
Negative
Good.
1/4.
Negative 1, 1, 2, 3, 4. Okay, good. And then how do I put that into my equation? Good, you plug in the x and the y. So I'd write this as, I'm going to keep it the same way, y equals a, and then in my parentheses, it's going to be x what? X plus 1 squared. And then at the end here, it's going to be plus 4. So remember that whatever goes in the parentheses is always the opposite. Okay? All right, now, in order to find the a value, we're going to be careful with these now. Okay? And so I'm going to choose a point on the graph. I'm going to go ahead and choose this point right here. And what ordered pair is that point? 1, comma, 0. So this is my x and this is my y, and we're going to plug this in here and solve for a to make sure we actually have the correct a value. So I'm going to have 0 equals a parenthesis 1 plus 1 squared plus 4. Are we good? Okay, what's 1 plus 1? 2. What's 2 squared?
4.
So I actually have 0 equals 4a plus 4. And then in order to solve for a, what would I do now?
Subtract 4.
Good. Subtract 4 to both sides. I have negative 4 equals 4a.
Divide by 4.
Very good. Divide by 4. And a equals what?
Negative 1.
Negative 1. So this right here is what I'm going to end up plugging in for a in the front. So we're going to write our equation right here. So they have f of x, and then what will come next?
Y.
Negative 1, or we can just put a negative, parenthesis, x plus 1 squared plus 4. This next part is when we're going to use our just your domain part, but I'm going blank on the word I'm trying to use. Your inequality, okay? Telling what x is supposed to be in between. So what is the smallest x value that you can have on your graph? Negative 4. So look here on the x value, okay? So when you're doing your restrictions, it's dealing with the x. And so I'm marking kind of my x values right here. So the smallest x value is down here, and that's at negative 4. Is that open or closed there? Closed. So that means I'm going to have negative 4 is less than or equal to x, is less than or equal to, and then what's the largest x value? 1. So that's telling you that the graph can only be between negative 4 and positive 1. Are we good? Okay. What type of graph is the next one?
Absolute value.
Good, absolute value. And the important thing with the absolute value is that, again, we need to start with our vertex down there. And so what is that vertex? Oh, and I'm going to put here y equals a absolute value of x. That's kind of our generic equation for absolute values. And so what was this point? What is our...
1, negative 3.
Good, 1 comma negative 3. So when I plug it in here, we will have y equals, I'm keeping it as a, and then what goes inside there in the absolute values?
1.
Not 1,
X.
x minus 1.
Oh, that's right.
Okay, and then what goes at the end?
Minus 3.
Very good. And we're going to do the same thing just to be safe by plugging in a point to make sure we do everything correctly. Or do you not want to do that? Because on absolute values, you know it is exact because it's a line. So can you guys tell what the slope is for a on this one?
Yeah.
What is it?
1.
1. So this is really just a 1, which means we don't even have to have it, right? And so when I'm writing my function up here, I would just write absolute value of x minus 1 minus 3. Do you think that you can go ahead and write here the inequality for your restrictions? So again, you're only talking about x's when you're giving your restrictions on this. Okay, so what's my smallest x value? Negative infinity. Now, I'm going to write this down here because this isn't exactly how we're going to do it. So you know how you would have like negative infinity, negative infinity, and then it's going all the way to 2. Do you guys agree? But this is not inequality, that's interval. So how would I write this? What do you think I would write in order to use an inequality? What does x have to equal? Very good. So it should be if x is less than or equal to 2. Because we're basically stating everything less than 2 will work. Okay? Questions?